Okay, so today we're going to be talking about graphing exponential functions. So we've been looking at, properties of exponents and simplifying and radicals. So today we're going to look at a visual here of graphing. So graphing exponentials. Graphing x. Now, first thing when you're graphing is you need to think about the horizontal asymptote. So, if I have a function that is in standard position, we say it equals y equals a times b to the x plus c. And this plus c part represents the vertical shift. Remember, if you add outside, you're shifting a function up or down. When it's in standard position, the horizontal asymptote is at 0. And an asymptote is a line, like an invisible line that your graph gets infinitely close to. It can cross over it, but it never actually becomes that straight line. So here, the first thing I want to look at is I notice that there's no c. So I have plus 0 here. So my horizontal asymptote is going to be at 0. So I'm going to put in a dotted line at 0. So that's step 1. Draw in horizontal asymptote. And that's basically just your c value. Okay, whatever's being added or subtracted outside. Now, the next thing I want you to do is find your y-intercept. Now you find a y-intercept by substituting 0 for x. So I'm going to go ahead and substitute 0 for x here. We'll write that down. Make x equal 0. So I have y equals 6 to the power of 0. Well, anything to the power of 0 is 1, so that means y equals 1. So my point is 0, 1. Remember, we made x equals 0. When we put 0 in for x, we got y equals 1. So I'll plot that point over here, 0, 1. Now the next thing you need to do is identify, is it exponential growth or exponential decay? So that's step 3. Growth or decay. So you know that by your b value, and in this case b is 6. So if your b is greater than 1, then it's going to be exponential growth. And if your b is between 0 and 1, so bigger than 0 and less than 1, it's going to be decay. Sorry, it's kind of sloppy. So here we have 6, and 6 is bigger than 1, so this is going to be exponential growth. So what I'm going to do is I'm going to draw my graph, and from the left to right, it's going to grow exponentially. And notice that on the left, it gets really, really close to this horizontal asymptote, but it never actually touches it. And that's it. There's my graph. Let's look at another example here. So remember, first, I need to identify my horizontal asymptote. There's nothing being added here, so that's plus 0. So my horizontal asymptote is y equals 0 again. Remember, to write the equation of a horizontal line, it's always y equals, and then the number. Second, I want to find my my y-intercept. So I make x equals 0. So this becomes y equals 3 times 1/2 to the power of 0. Remember, you do exponents first. So this becomes 3 times 1, which is 3. So my y-intercept is 0 for x and 3 for y. So I'm going to come over here and plot it, 0, 3. And then I want to think, third, is this growth or decay? Well, this value here, this 1/2, tells me whether it's growth or decay. 1/2 is between 0 and 1, so I know that it's going to be decay. So whenever you have a number between 0 and 1, it's going to be decay. So when I draw this in from left to right, as I go to the right, it's going to get really close to my horizontal asymptote. Okay? So a trick for your horizontal asymptotes, if it's growth, or I'm sorry, for growth and decay, growth means when you go left to right, your graph goes away from the horizontal asymptote. When you have decay, I don't know why I keep forgetting the C's. As you go left to right, your graph goes towards the horizontal asymptote. So notice as we go left to right, our graph is getting close to the horizontal asymptote. That's why it's decay. All right, let's look at a couple others here. So step 1 is find your horizontal asymptote. Again, there's no plus anything here, so my horizontal asymptote is y equals 0, and make sure that you're writing it as an equation. So there's my horizontal asymptote. Step 2, my my y-intercept. So my y-intercept is y equals -2 to the power of 0. Notice that this negative is outside, and just the 2 is to the power of 0. So this equals -1. So my y-intercept is 0, -1. So I'm going to plot that. Now I need to think, is it growth or decay? And this is going to be growth because this quantity here, this 2, is bigger than 1. And notice I'm just talking about the 2, not the negative. The 2, so it makes it bigger than 1, so it's growth. Now what this negative does is it reflects it across the x-axis. So it goes from the top to the bottom. So just note the negative reflects across x-axis. So instead of being above the x-axis, it's going to be below the x-axis. And because it's growth, as I go left to right, my graph is going away from the horizontal asymptote. So it looks like this. And that's my graph. Okay, another example here. So first, find your horizontal asymptote. My horizontal asymptote is this C value. It's been shifted up 2 spaces. So my horizontal asymptote is y equals 2. So I'm going to draw that horizontal line in. Step 2, I want to find my y-intercept. So I'm going to make x equals 0. So you get y equals -3 times 1/4 to the power of 0 plus 2. Anything to the power of 0 is 1, so you get -3 times 1. So this is -3 plus 2, which is -1. So my y-intercept was 0 for x, and I got -1 for y. So that's going to be 0, -1, so that's down here. Now, next I need to decide, is this growth or decay? Okay, so this number inside the parentheses here, that tells me growth or decay because it's between 0 and 1. It's decay. So as I go left to right, my graph is going to be going towards the horizontal asymptote. And note here that that negative reflects across x-axis. So it's like flipped upside down. So your graph's going to go like this. It's going to pass through your y-intercept. It's going to get close to your horizontal asymptote. And that's it. So you guys have, you don't have to do this. It's just a worksheet. So go ahead and get started on your homework.